All right, in this video we are going to go through multiple different sketches. I am going to use sine, but you can use cosine as well. You just need to remember the basic structure of cosine. So I'm going to start with this one where a is some given number. So let's start by sketching sine. Here's 1, negative 1, sorry, and here's positive 1. Sine always starts at 0, and I'm going to come out here and go pi, 2 pi, and then this is 3 pi over 2, and then this is pi over 2. We need these points because these are all zeros and ones. So we start at 0. By here we're at positive 1, then we're back to 0, then here we're at negative 1, then we're back to 0. This is what the sine function looks like. I have not changed it. I simply am drawing the sine function. Okay? So this is sine. If I have an a, that means every point gets multiplied by this number. So if, let's say a is a positive number, 0 times that positive number will still be 0. So this could come up to a. Okay? And then this one would be 0 still, and then this one would come down to negative a, and then be 0. The only way that this would switch is if I had like a equals negative 1/2. Okay? Since this is less than 1, it's going to be smaller than 1. And since it's negative, it's going to flip my graph. So if I took 0 times 1/2, I'd still be here. If I take 1 times negative 1/2, I'm at negative 1/2, that's here. Okay? And then 0 times negative 1/2 is still 0. Negative 1 times negative 1/2 is positive 1/2. So if my a is negative, it flips my graph. Okay? So if a is greater than 1, it's going to stretch these points up. If less than 1, down. And if negative, it's going to flip my graph. So instead of going up first, it will go down first. But if you start with this, you should be okay. Now, what if I have just the sine and I'm adding something to it? Okay? So let's start by sketching my sine again. Here's 1, negative 1, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So, starting out, I'm just going to sketch sine. Okay? Now, this plus d gets added to each point. So, let's say d is positive. If I'm at 0, I'm going to go up to d. Okay? And then here, this is going to go up to d. And then this one will go up by d. So this will be 1 plus d. And this point will go up d. And this point will go up d. And so this will be negative 1 plus d. And then this will go up d. So what I'll do is I'll end up with this graph that is just shifted up by d. Okay? Notice my new 0 is here. Okay? D is my new 0. That is the axis where 0 will lie. And it simply shifts the graph up or down. If D is negative, it will shift it down. So what if I have a phase shift? This is called a phase shift. So this is an amplitude. When A is just 1, my amplitude is 1, but A is my amplitude. This is a phase shift. That means I'm going to move my graph over C. Now, I want you to know that if C is less than 0, so C is negative, then we move in the positive direction. And if C is positive, then we move in the negative direction. So again, I'm going to start by graphing a sine theta. So I'm just going to say that this is negative a, and here is a, and here is 0. pi over 2 pi, 3 pi over 2, 2 pi. Okay? So we're going to start by graphing regular sine. Oops, this is 0, not positive 1 again. All right. Now, using this, these are going to shift in the direction of whatever C is. So I'm going to assume that C is negative, so I'm going in the positive direction. This one is going to go over by C, and then over by C, and over by C, and over by C, and over by C. Okay? So you would take 0 plus C if it's negative. Okay? And you simply get this new graph. So that you have a new graph that's been shifted over by C. And again, A is the amplitude, so that's how tall I am instead of being 1. So this might be 1 here, and here might be negative 1. But I'm going to A because of this A. Last sketch problem. This one changes the period. Okay? So I'm going to start by graphing, but I'm going to make a smaller graph because I want you to see how the period changes. Here's pi, 3 pi over 2, here's 2 pi. Okay? And here's 1 and negative 1. And I'm assuming you can deal with the amplitude as needed, but we need to deal with B. So for example, I am going to say B is 1/2. No, I'm going to say it's 2. I'm going to say it's 2. 2 is easier than 1/2. So times 2. Okay? Let me rewrite this. I'm going to say this is simply sine 2x. Now, I know that this point is at 0. This point is at pi over 2. So I'm going to start by making my graph here. So 2x, and this will be y. So 2x of 0 will be 0. And then this one, when it's pi over 2, will be 1. And then normally at pi, it will be 0. And at 3 pi over 2, it will be negative 1. And at 2 pi, it will be 0. Now, I'm telling you this because I want you to realize that it's going to create this graph. And this will always be true. The trouble is, this is not x. This is 2 times x. And I would get this graph. Okay? So then the question is, what is x? These are the points I know, and that is this value. Whatever is inside, okay, are the points I know. But now I need to solve, so I need half of 0 to be 0. Half of pi over 2 will be pi over 4. Because 2 pi over 4s will be pi over 2. And then this will be pi over 2. And then this one will be 3 pi over 4. And then this one will be pi. Okay? So now, my graph. And this is where my A's will come in, because this just gave me the idea. And then remember that these would all be, this would become an A, and this would become a negative A. So, I start here. Here's pi over 2. Here's pi. 3 pi over 4, or 3 pi over 2, 2 pi. So, if this is pi over 2, that means here is pi over 4. Okay? These little dots in between are pi over 4s. So I'm going to start at 0 and be 0. Pi over 4, I'm going to be up at a. At pi over 2, I'm going to be back to 0. 3 pi over 4, this one, I'm going to be at negative a. And then pi, I'm going to be back at 0. Okay? This sped up my amplitude. Okay? And it would repeat through here. And you'd have it twice. So where it took one wave, it now does 2 waves. Okay? So my period is now pi. The way you figure this out for your period, because you will have a problem where you need to find your period, you take 2 pi over b. So in our case, we do 2 pi over 2, which would give us pi. That means every pi distance I have a full wave. And that is all of your sketching problems.